Now it's recording.
Okay, so we're working on more applications of derivatives, specifically graphical applications. I think this should actually go fairly easy for you, being we've kind of done some of the tougher stuff with velocity acceleration, some more of the story problems already. But if not, we'll continue to rep it. It's a lot of the same stuff, though. We're doing derivatives, we're doing different things with those derivatives, and then coming to some conclusions about the graphs of certain functions. Okay? When we think about properties of graphs, all right, some of the things that you will be asked to find are when is it increasing or when is it decreasing. So those will be some things that you'll be asked to find. And this isn't just you graphing the function and then seeing where it goes up and seeing where it goes down. It's really you not even having to graph the function in order to determine that answer. It's calculus to determine those things. So intervals where it's increasing, decreasing, extrema. Okay? Extrema would be like all of your relative max, relative mins, absolute maximums, absolute minimums, tops, bottoms, however you want to call it, of the graph. Okay, that's what extrema is. Another thing we'll talk about, not today, but the concavity intervals. We've mentioned it slightly before. When is it concave up? When is the graph concave down? Okay. Another thing we'll eventually do are inflection points. Okay. Those are that's where something switches from concave up to concave down, or vice versa. Okay. So these are a few of the things that we will use calculus to help us find with properties or with these graphs of these certain functions that we'll be doing. Okay, so I just kind of wanted to give you a list of some of the things that we will be doing before we do anything. Okay. If you want to follow along, or there's actually some good pictures in your textbook on page 164. Okay, we are on page 164 in your textbooks. Extreme value theorem is one of them, one of the concepts that you'll be using. Okay? Basically, the extreme value theorem says if I have a closed interval, all right? Not sure what happened there.
It lagged.
Okay? If I have a closed interval, so a function on some sort of closed interval, you are guaranteed to have an absolute maximum and an absolute minimum on that closed interval. Okay? As long as it's continuous. Okay? If f is continuous on a closed interval, so if I have a continuous function from here to here, you are guaranteed to have an absolute max and an absolute min. Alright? So you'll be able to find one of those for sure every single time. So that's kind of your extreme value theorem. If you want it written out in words, it's on page 164. If f is continuous on a closed interval AB, then f both has a minimum and a maximum on that interval. Okay? So f is continuous on a closed interval, then min and max occur. Kind of in a nutshell. Extreme values theorem. Basically saying if we have a continuous function on a closed interval, there are extreme values. There are maxes and mins. Okay, so you'll be able to get both. Okay? How do you find those? Well, specifically, you will be able to find what are called the critical numbers. Okay? very common word in calculus, are the critical numbers. Here's the book's definition. Let the function f be defined at point C. If f prime of C equals 0, or it is not differentiable at C, then C is a critical number. Okay? So if the derivative equals 0, or if it's not differentiable, or the derivative is undefined in a sense, then C is a critical number on that function.
So, if that's to be true for like some of our piecewise when it doesn't go to the same point, then wouldn't that mean that there'd be a max and a min at the same area in a sense? That's not a very good way of saying it. Because like one of the functions that we couldn't differentiate is when from the left it's reaching to about here, and from the right it's reaching to another point. Then it's not differentiable, correct?
If they're
Approaching different numbers.
correct, yeah.
Then never mind. I think I get it.
Alright. So really what I'm going to do today is we're just going to practice finding some critical numbers. And really, again, all it's going to involve for the most part is you setting derivatives equal to 0 and finding their values.
So
Okay?
we've basically already done this. We just haven't like put it in these terms.
Yep. Okay. Let's see, I'll do x plus 4 over x squared, and let's find critical numbers. Okay? Find the critical numbers.
Find derivative, maybe equal 0.
Yep, so find the derivative, and set it equal to 0, and then solve for x in order to find your critical numbers. Or, if it was ever undefined, in a sense, that could potentially also be a critical number if it's still in the domain. What number is not in the domain of this function, though? What number can you not?
0.
Yeah, you can't have 0. X cannot equal 0. Okay, so 0 cannot be a critical number because it's not even in the domain of the function. Okay. I would probably rewrite this first.
But wouldn't that mean it's an asymptote there, thus making it not differentiable? And didn't we just say that if it's not differentiable, then it's a critical number? Or
At point C.
F has to be defined at C, though.
got it. I see.
Rewrite this.
Yeah.
Yep.
What'd you get?
X
Set
plus
what?
4x. Okay. Then you can do your derivative. What would it be?
1 plus.
8x
Oh,
to the
it's-
negative third.
Good. 1 minus 8x to the negative 3. Set that equal to 0.
So you leave it. Leave it alone.
It's up to you. Yeah, if you want to write that as 8 over x to the third, that's fine.
No, no,
Can we do it that way too?
no. I was just.
Okay. No, that's right.
Then wouldn't we want to subtract 1 from both
Subtract
sides?
1 works.
And then divide by negative 8,
Divide by negative 8 works.
so 1/8. And then cube each side? No,
No, third
negative
root
cube.
each.
How about raise both sides to the negative 1/3?
So,
Yeah.
cube root E7.
Yeah.
Negative
Negative cube root E7.
1/3. Because I really just want x to the first power, right? Okay. So I want x to be raised to the first power, while this right now is being raised to the negative 3 power. Okay. How could I make a negative 3 power become a positive 1 power? Multiply it by negative 1/3. And so that's why I'd raise both sides to the negative 1/3 power. Don't like that, do this instead. I saw a lot of blank faces. X to the negative 3 is 1 over x cubed, right? Now you could do cross multiplication and solve. Now you could also notice that what number cubed would be the same thing as 8?
2.
2.
Yes.
I mean, there's maybe some easier ways to get your answers there. So write it this way if it helps you, but like I said, I think you could just raise both sides to the negative 1/3 and you'd also get your answer. A lot of ways to solve that one.
Okay.
So x equals 2 would be a critical number. We're not going to do anything more with it. We're just going to find our critical numbers. Okay?
The test is what the critical number is, I think let's do whatever.
If the directions say find the critical numbers, you can just write x equals 2. Yeah. Since I didn't have the directions up here written, find the critical numbers, I wanted to make that clear just for the video and for you guys. So, all right. Okay. How about a little trig?
Yeah.
Let's go sine x minus cosine x. And let's use this interval. 0 to pi.
Actually,
Oh, it's
oh, never mind, it's different. I'll just go with
Is
this
it
one then.
minus with that?
Yep, sine x minus cosine
Oh,
x.
what's we're doing x equals, never mind.
Cosine x plus sine.
One time.
Cosine x plus sine x. And what?
Is equal to 0.
Is that equal to 0?
Doesn't cosine plus? Oh no, that's a square. You just don't close on.
Does it have any
It's
critical?
one of the, yeah, cause then,
I'd probably do this and then come up with the values that are correct.
so wouldn't it be one of the 45 degrees?
Correct.
Which one? So to get it negative.
When are cosine values and sine values the same? That's like asking when are the y values and the x values the same on a unit circle? Well, the only time the y value and the x values are the same are when you're exactly at 45-degree angles. You'd have x's and y's that are the same. But in the first quadrant at pi over 4, both the x and the y are both root 2 over 2. They're both positive. We need them to be opposites of each other. So in what quadrants would you have opposite answers for sine and cosine?
2 and 4.
2 and 4, because in quadrant 2, sine is positive, but cosine is negative. Down in quadrant 3, they're both negative, so that would not match right here. And down in quadrant 4, cosine is positive, but sine is negative, so they're opposites. Okay? So if we're working quadrant 2 and quadrant 4, you got your 45-degree angles. What are they in those two quadrants?
135.
In degrees, 135, yes.
Yes, 4.
But we want them.
3 pi over 4
7 pi over 4.
Seven pi over eight.
and 7 pi over 4.
Well, the intervals and radians.
Okay. Yes, yes. Yep. So those would be your critical numbers here.
So basically, you just have to go through and eliminate the like five of the signs out there. If we can, does that make sense?
Say that again, Ben. Sorry.
So like, when we do this problem, we have to go through just different, like, not differentiate, but like single out what equals what on there in the unit circle.
Yeah, yep. They're gonna be easy enough to do. They're gonna be, nice answers that you can get off of your unit circle. Okay. Do you have a copy of the unit circle?
No, but we should have one.
We can make more copies
That'd
of
be
that.
great if you,
Mm-hmm.
Yeah.
Get those on
I
the
would
test?
appreciate
Okay.
that.
Yeah.
Really?
cause we're not testing it for
You know what
trig, we're
we should
testing it
do?
for ribbon.
I mean, you don't get that on your AP test.
Yeah, you do.
You do?
You get, there's this sheet that you get all the equations on an AP physics test.
What about AP calc though?
Oh, that's what I meant. I meant calc.
You
Yeah.
do?
Yeah, they have a sheet.
Yeah.
I can get you a copy of it from Central.
Yeah.
You should do
You
that
should,
to see
yeah.
which ones we should get.
That's good to know.
Thanks, Carmen.
Yeah.
So,
So,
I'm gonna throw it away.
I don't know if the unit circle is on there, but I
Sure.
know that like most of the equations are on there.
Well,
I was talking so bad.
gotcha.
Good man.
Okay. So, there would be your critical points.
Save you a couple
I don't think I can continue.
Everyone's doing that in the bird. I thought you said I like the birds.
Alright, so why don't you guys, for practice here right now, let's do page 169, 11 through 16.
Yeah,
This is
See if you guys can get those done here in the last 20 minutes.
Was that our assignment?
Okay? Yeah, I'm trying to decide if I'm gonna do more though.
no, you don't need
Yeah, let's do more together.
You like this today?
Just work, so I can know if you got it.